So before we get to our lesson today, you guys asked some questions, some good questions on homework from 2.2 Part 2. So we're looking at page 104. And this is 2.2 Part 2. So what we assigned on Monday. So the first question was actually the first question that came up. Number 43 was some data about, what was it, about water levels for the Wisconsin's Rainbow Reservoir in the year 2007. So in their chart, they refer to it measured by months. And if you keep reading in the blurb underneath the chart, it says, to write a model that best relates the water level as a function of number of months since January. So if you decided to call January 1, you're going to get a different model than me, but because you're going to use your model appropriately, you'll get the final answer to be the same. But I'm going to follow what they wanted me to do, which was calling January is actually 0. So February would be 1, and so on and so on. Now be careful. They go through February, March, April, May. They skip June. So like when you get to May, you'll call that 4. They skip June. The next data point is July. So you will call that 6. And then they go August, September. They skip October, right? So you'll get to September. You'll call that 8. And then you'll skip down to November. You'll call that 10. And December is 11. So those are all the X's. I think I didn't write all of them down, but you get what you're doing there for the X's. And of course, you'll just, plot them against their Y values. And then what you have to do after that is you have to take a look at your scatter plot. Because they didn't tell you like what type of regression to use. And this is not a time where you want to guess and check until you get a good regression, because looking at the scatter plot will answer it for you. When you guys get these data plots typed in, it looks something like this. And, you know, if you squint, it's going to kind of resemble one of these guys. So your choices for regression are linear, quadratic, cubic, quartic, and then we saw a weird one called power regression, which is just basically fancy polynomial. So this one's pretty clearly a W shape. This is a quartic. So I would use the quartic regression, and y'all were freaking out at first. You're like, wait, I'm supposed to know which one to use. I mean, in theory, yes, because you can look at the scatter plot, but on the test, I will tell you which regression to use. So don't panic about that. All right. That's about all I'm going to do on 43. I'll let you guys finish that one up. 55. All right, so this is where I admit I did a terrible job of explaining a concept. But unfortunately, the next like 3 days of lessons, they all kind of blend together into one gigantic fundamental theorem of algebra, which is like a huge topic. So I was kidding with somebody this morning. I'm like, yeah, all those kids who are going to wait to the last minute to do their homework, they're going to be fine because they're going to know all about this. But you go-getters who actually did your homework on time, you were a little confused on 55. So 55 says you have a degree of n. All right, buddy. Degree of n. So they told you it was a degree of 3. And then they said you only have whatever real zeros are listed. So the only 0 they gave you was at 3. So what that tells me is you have a polynomial. If it has a degree of 3, that means you have 3 factors, technically. But it went ahead and said, no, 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 the only real 0 you have is at 3. What does the factor look like if your solution or your 0 is at 3? X minus 3, yeah. So you have some choices here. You have a couple different things you could do with these other 2 factors, because they do exist. So someone said, well, could I just say this? Yes. Would that have a degree of 3 with only a real 0 at 3? Absolutely. Someone said, well, what if we had a problem on our notes where there were 2 other zeros, but they weren't real? So if you're not real in math, that means you're imaginary. So what you could do is you could create these 2 to be imaginary solutions. But something you might not remember from algebra, we are going to discuss this in detail on the next lesson, is that if you have an imaginary solution, like let's say 3i, his complex conjugate has to be along with him. They come in complex conjugate pairs. So if x minus 3i is a factor, x plus 3i is also a factor. So it's up to you guys how you want to attack the next question. For those missing factors, you could either create multiplicity, or you could decide that they're imaginary solutions. But what you can't do is introduce additional real zeros. So like when you look at 57, they want you to have a quartic, so a degree 4, but they only give you 2 zeros. So you either have to give multiplicity to them, or you have to create imaginary factors that come in a pair. So totally up to you. And it even says in the directions, like, answers will vary. On my key, I wrote there's many, many, many answers you could give here. So if you don't want to think about imaginary solutions, you just think about multiplicity. That's fine. This could be anything. So it could have been 2i, I, 7i, 11i, as long as it was something with an I in it. And then his conjugate would have to be paired up with him. As long as it's imaginary, because I couldn't introduce another real solution. Very good. So you either go the multiplicity route or you go the imaginary solution route. Your choice. All right, and then someone asked about number, I forgot what the last one was, 66 or something? All right, so on that one, I'm not actually going to do 66 or 67 for you. I'm going to refer you to the front of your chart. There's a chart on the front of your notes. So I'm not talking about yesterday's lesson, but the lesson from before this, where it said if you have an even degree, your end behavior either goes up, up, or it goes down, down. And how do you know whether it goes up, up, or down, down? Think about the most basic even degree function you can, which is your parabola. How do you know if it opens up? If the a value, the lead coefficient, is positive. So if the lead coefficient is negative, it's going to open down, down. What about an odd function, odd degree function, excuse me. So either the ends go down, then up, or the ends go up, then down. And how do you know? It's because of the lead coefficient. So if your lead coefficient is positive, the ends go left, down, right, up. And if the lead coefficient is negative, it flips, reflects. And then someone asked me, how am I supposed to know that? And then I'm sorry to tell you the answer is you're just supposed to know that. It's one of those things you need to memorize, okay? Sounds great. Can't wait. Now, guys, you do have a graphing calculator. So if you're ever like, oh snap, I can't remember if x to the third goes down left or up left, you could always graph it. Okay? All right. I think that pretty much covers all the concepts on the homework. You guys have it from there. Could you find worksheet 4B, please? Mm-hmm. It doesn't have to be imaginary. It could have multiplicity. So, like, you have to have, if it's degree 4 on the next one, you have to have 4 things. So whether 4 factors. So, like, on that one, they give you 2 zeros to work with. So you could say, like, this one shows up twice and this one shows up twice. That would add up to 4. Yes, it says, like, n equals 4 in the problem. That's the degree. All right, guys. So this, yeah, this worksheet is part of your homework check, actually. Yeah. Wow. I think so. I don't know. You guys picked up your homework check a minute ago. It is. And, well, there's a due date at the bottom. Does it say Monday? 10/23. Oh, that feels like, what day is that? What? 23? It doesn't feel right. I feel like it's due Monday. That makes more sense. Summative says that. The summative, yes, the summative is on the 23rd. I gotcha. Okay. I was like, that doesn't fit my plans at all. So the homework check's going to be due Monday. But I think we've all caught on that this is not a good week to like put off homework. This is going to get a little rough. So stay with me, guys. All right, today, whatever I don't get done on this worksheet is yours for homework. So I don't plan on doing all of it. Don't get excited. We're going to be writing equations of polynomials. Oh boy. So let's start with, I guess we're going to do numbers 1 and 4 together, which means you guys get to finish the other ones. So this feels like an important clue. And this feels like an important clue. And this feels like an important clue. And there's another clue up here where it says the y-intercept, f of 0, is 16. That's the ordered pair 0, 16. What is this first ordered pair here? I mean, they didn't label it, but I think I'm to assume that that is the ordered pair -2, 0. And then this one is labeled because it wasn't so pretty, and so is this one. So these things that I circled in red, those are x-intercepts. And we have to remember something called multiplicity. Do you remember what it looks like when there's even multiplicity? It bounces off the axes. Do we have that going on here anywhere? No. So all of these zeros are going to turn into factors that just show up one time in our problem. So here's what I'm going to need you to do. You're going to write out y equals. You can call this first value a, or you could call it any variable you want, but if you want to kind of stay consistent with what you're going to see on a test, your test calls it k, but you could call this variable anything you want. What I need you guys to do is kind of go backwards and fill in your factors that would have produced all of these zeros. So there's a couple of different answers, but what would be a factor that would produce an x-intercept at -2? X plus 2, very good. And then here, you can say x plus 4/3. There's other things you could say here, guys, but for now, let's just say x plus 4/3. And then for this last one, let's call it x minus 1/3. Well, that's fantastic, but there are 3 unknown things there, and I feel like we've never had a problem where we walked away with 3 unknown things. Our job is to come up with the equation. Y and x are acceptable variables in equations, but that's not. So remember that other clue? There's an ordered pair that was given to you of 0, 16. 0 is an x value that pairs up with 16 as a y value. You're going to plug in all of those for where they belong. Here we go. Instead of y, we're going to write 16 equals, I have no idea what k is, leave it alone. And then x, for all of these x's, we're going to use a 0. So we have 0 plus 2 times 0 plus 4/3 times 0 minus 1/3. Okay, this should be fun. I need to figure out what all 3 of these guys are when we multiply them together. So to avoid a lot of typing, I'm just going to type, or I really don't want to think about this morning. I'm just going to type it. 2 times 4/3 times -1/3. And by me, I mean you're going to type it. Is it -8/9? Okay. So this green stuff here, this is -8/9. And I'm just using my algebra skills. I'm trying to solve for k. So next easy step would be to, you could either divide by -8/9 if you use parentheses, or you could multiply by the reciprocal, which would be -9/8. So y'all just found out that k is something. What is it? Is it -18? Oh boy! So we're like super done, right? No, we're not done. You guys got to go back up to this line right here. This very first one we wrote down. Everything was beautiful there except the thing that was called k. We had to find k. Y'all just found k. So if you have an eraser, you can just go back and change k out for -18, or you could be a good kid and just write down the new equation. -18 x plus 2 x plus 4/3 and then x minus 1/3. That is a great answer for us today. I mean, technically I could make you FOIL all that out, but I'm not gonna. That'd be terrible. So these are fun. Please, let's do another. All right, I'll do number 4 with you. That seems like a fair exchange. 4 is the worst one, by the way. So you're welcome. All right, here we go. Let's talk about what's going on right here. I see that there's something happening at -3, 0. But let's use some vocabulary. It seems to be bouncing off of the axes, so what does that mean to you? There's multiplicity, and if you had to take a guess, what kind of multiplicity are you thinking? If it bounces, it's going to have to be even. Let's just assume when it bounces for us that it's just multiplicity 2. One could argue like, hey, what if it's multiplicity 4? Because it's very hard for you guys to tell the difference between multiplicity 2 and 4, especially on a graph like this. So let's just make a statement. If it's bouncing, it's multiplicity 2. All right. What's going on right here? That's an intercept of 0, 0, so that's just a one-time intercept. And then this guy here, it's bouncing again, isn't it? So that's a multiplicity 2. So they gave you a couple of ordered pairs at the top. This 0, 0 one we're going to use as an intercept. This other ordered pair, this is the one that I'm going to have to use at the end of the problem. Oh boy. All right. Here we go. I'm going to get rid of that. Let's start writing down what we know, guys. And sometimes kids want to kind of jump the gun and go ahead and plug in the y and the x right away. I might encourage you to do that as you're practicing, but I don't know if right now is a moment we're comfortable with doing that. So let's just write down y equals, there's going to be a k value that I do not know yet. And then I'm just going to start on the left here. So we have an x-intercept, well, as a 0 technically, at -3. So what does that factor look like if it's got an intercept or a 0 at -3? X plus 3, but you guys made a note that it bounces, which means it has multiplicity 2. So that means this quantity is squared. Instead of writing it twice, I'm just going to call it squared. There's also an intercept at 0, which if you want, just for the sake of consistency, you can write it as x minus 0. That's what I'm going to do. And then again, there's a x-intercept or a 0 here at 5/2, so that's x minus 5/2, but we wrote a little note that it bounces, which means it has multiplicity of 2. So this would be fine, except I have no idea what k is yet. So we're going to use this extra ordered pair they gave us. We're going to plug in that x and that y everywhere we see an x and y. All right, here we go. Was it -28.8? Okay. -28.8 equals, I do not know k. And the x I'm supposed to plug in was 1. Oh boy, here we go. So, that's a lot of fractions going on, guys. I don't know about you. I'm not feeling any mental math at the moment. So everything that I just bubbled in green, I'm literally going to type in from left to right in my calculator. And it looks like it's going to be a nice whole number. So that's good news. Go ahead and type it in. Not even a fraction. Make sure you don't leave off these squares. They're very important to your problem. They are squared still. Does it come out to 36? Awesome. All right, so we have -28.8 equals k times 36. All right, easy peasy. Divide by 36. Now, I think this, right now it's a decimal probably on your calculator. Is it -0.8? Okay, so it's a truncating decimal. I'll accept -0.8 as a k value. If you want to math enter that and bring it back to -4/5, that works as well. But the point is, you guys got to come back to this line right here. And you have to place the k where it belongs. So y equals, you guys just found that to be a -0.8. And then please don't forget any part of this. Now there's one modification to this answer that you might see. Anyone think they know what you could have done to make it a little prettier? Has to do with this term right here. Do we normally write x minus 0? That's kind of a weird term. What do you usually write instead of x minus 0? Just x, yeah. And does the order of these parenthesis sets matter? No, they could be really like rearranged all over the place. So if I was like a computer generated key that I was looking at, they probably would have put -4/5 x and then x plus 3 squared and then x minus 5/2 squared. We'll discuss in an upcoming lesson other ways that we could write the factor of x minus 5/2 because there's actually a different way to write that. But for now, all I need you guys is to follow those steps. So that's super fun. Oh, it gets better after this. The rest of that's assigned for you. So you have 3 problems to finish. And that was the nastiest one, so you'll be fine after this. What I need you to do is... Oh, I don't have that lesson. I need you to find worksheet 5. All right, so worksheet 5, we're only going to do about half of it today. And our job today is just to remind you how to do what's called long division and synthetic division. The day just keeps getting better and better, doesn't it? Okay. Well, we got 20 minutes to remember how to do this. So that's obviously little kid long division. We got big kid long division coming our way. Why not? All right, so this first question here, this is already done on your notes, so you're just going to kind of work along the board with me. Try not to look at your notes for any spoilers here. But what I do want you to recognize is right here on this first warm-up question. We have an x to the third, and then do you notice how there's no quadratic term? There's no x squared term. So a good habit to get into in all types of division for polynomials is if you're missing a term, go ahead and put a 0x squared term. So this way, remember when you're a little kid, you always need the terms to line up. Otherwise things didn't work out. You didn't really understand that as a small child, but now as an older child you understand that you need your like terms to line up. That's what we're shooting for here. So long division is a series of 4 steps until you get to the end of your problem in which you may or may not have what's called a remainder. So you take the dividend, the first lead term of the dividend, 3x to the third power, and you are dividing it by the lead term of your divisor, which is x. So what happens when you take 3x to the third and you divide it by x to the first? You get 3x squared. That gets written up here. So that's the first step in long division, to divide. Then what do? Then you multiply. So you take the 3x squared and you multiply it by your divisor. The entire divisor though, right? So that gives you 3x to the third power plus 3x squared. And then what do? Because we're going to subtract. So what you're doing is you're figuring out, so we divided and now we're trying to see how much is still left over in the division question. So your little kid teacher and then your Algebra 2 teacher last year was encouraging you to do one of these. This part is usually where kids mess up. The first term should always cancel, otherwise you've done some bad division. The next term usually does not, so 0x squared minus 3x squared is negative 3x squared. And then, I need another color. The fourth step is that you bring down the next term so that you have created a new, smaller polynomial. So we bring down. And now the process starts all over again. So that's the whole process of long division, is to go through those 4 steps, whittle it down to a smaller and smaller polynomial until you no longer have anything that can divide. So we can still divide here, guys. So this is our new problem right here. Start over. So take your new lead term, which is negative 3x squared. And you're still dividing it by the lead term of your divisor, x. So what do you have when you take negative 3x squared divided by x? You have a negative 3x. That answer gets written up here. And now we multiply. So you take this thing that you just came up with and you multiply it into your divisor. So careful, it's a negative 3x times x plus 1. So that is, let's see, negative 3x squared minus 3x. And now we see how far away we are from the true dividend, so we subtract. Lead term should cancel, otherwise we've done something terrible. And then negative 2x minus negative 3x is positive 1x. You still have another term to bring down. And now we have to repeat the process again. So this is your new problem that you're looking at. You take your lead term, which is 1x, and you're dividing it by your lead term of your divisor, which is x. And when you take 1x divided by x, you get 1. So up here you're writing a positive 1, and you multiply into the divisor. You get 1x plus 1. Now we're going to see how far away we are from the true answer, so we're going to subtract. I think, maybe. So lead terms cancel, they do. Careful here, negative 4 minus 1 is a negative 5. So I have no more terms to bring down. You can't do weird things with decimals. So what do we call this last number here? We're stuck in the division. We can't do any more division. This is called the remainder. So how do we write our answer? Well, the quotient, which is the thing up top in blue, is the main part of the quotient, 3x squared minus 3x plus 1. But the negative 5 is still trapped in the division problem. So the remainder of negative 5, you can say plus negative 5 here. He's still being divided by the x plus 1. But pre-calc kids, would we usually say plus a negative anything? Isn't that kind of weird? So normally what your teacher would have you do is come through and change this just to a subtraction sign. Oh, their faces look really excited. Excited to do this again? It's back. Okay. Yeah. All right. Let's take a look at, let's just keep with long division for a minute. Can you guys look at, is this question on your notes? Okay. Yep, that's the one we're going to do. So let's set it up. This is your divisor, or sorry, dividend, excuse me. That goes underneath the dividing house. There are no missing terms this time, so you don't have to worry about any zeros. And we're dividing it by the divisor of 2x minus 1. I got in the habit of telling my Algebra 2 kids to put the 2x minus 1 in parentheses, and I think that would be a smart choice for pre-calc kids as well. All right, first step in long division is to divide. So you take your lead term and divide it by your divisor's lead term. Now this, I like to show off to the side because this is a very common place for kids to mess up. It's a big mistake when you mess up here. So 2x to the third divided by 2x comes down to nx squared, right? It is a 1, but yes, x squared. So now we multiply the x squared into the divisor, and we see how far off we are. So x squared times that becomes a 2x to the third minus x squared. And now we're going to see how far off we are because we're going to subtract. So the lead term should cancel. It does. And then you have 3x squared minus negative 1x squared, which gives us 4x squared. And then we bring down our last term here. Our next term, I should say. And now we have a new problem to consider. This is our new dividend. That's what we're going to start dividing into now. So starting all over, take your lead term of 4x squared and divide it by your lead term of 2x. So 4 over 2 would be a 2, x squared over x would be an x. That's a positive 2x, so up here above the division sign, you write a plus 2x. And then we multiply. So 2x times 2x minus 1 is 4x squared minus 2x. We're going to see how far off we are because we're going to subtract. Does the lead term cancel? Sure does. Good job. Negative x, 8x minus negative 2x is negative 6x. I always pause at that moment. I'm sure you guys can figure out why, because when I mess up on this question, it's right there. That stuff I just wrote in red, subtracting negatives, is the bane of my existence. Every time I mess up on these, it happens right here. It is right, what I have written down. But when I mess up, that's where it happens. Okay, bring down the next term. I used the wrong color. Start again. All right, here's your new problem. Negative 6x plus 3. We're dividing the negative 6x by the 2x. Almost home free. This is our last step, right? This becomes a negative 3. That's what you write up at the top. If it makes you feel any better, these are horrible to grade. Does that make you feel good on the inside? All right, negative 3 times 2x minus 1 is negative 6x plus 3. And then final step here, we're going to see if we're far off at all. We're going to subtract these, making sure those lead terms cancel. They do. 3 minus 3 comes out to no remainder. That's okay. We'll learn what that means tomorrow. But no remainder means I don't have to do any more work to write my final answer. This quotient is my final answer. So x squared plus 2x minus 3. No remainder, so you don't have that weird fraction thing. Woo! So some of you are having good memories from Algebra 2 about doing these. Some of you are having nightmares about Algebra 2. You just have to watch what you're doing. And what I would suggest, if you feel like your work gets away from you and you have some moments where you mess up, the stuff that I have done in red here, if you do that in another color, like if that's the only thing that's done in a colored pen on your work, it will help tremendously. The other thing I would suggest, kids who leave off the parentheses for the subtraction, because they're like, oh, I totally know to subtract. That's great, till you get to a test and then all of a sudden you don't. So you need to practice it the way you want to test it. Muscle memory, all that jazz, okay? Let's try some more long division and then we'll come back to synthetic division. Alrighty, here we go. This time, your divisor is no longer a two-term binomial. This time your divisor is a three-term trinomial quadratic. The process does not change though, guys. Nothing's going to be different here. So 2x to the third power plus 5x squared. Okay, there's no missing terms. That's good. And then your divisor, x squared plus 3x minus 4. Hi. All right, I don't know why that's so far over. There we go. All right, divisor, 2x to the third divided by the divisor's lead term of x squared. So I like, even to this day, guys, I still write this off to the side because this is easy to mess up. So this becomes a 2x. Now we're going to multiply the 2x into each part of the divisor. So this time you have a trinomial to distribute to. So you have 2x to the third plus 6x squared minus 8x. So the good news about having a larger divisor is that it actually shortens up your work and your steps because your terms can't, you go through your terms a lot faster. Lead term should always cancel no matter what your divisor is. 5x squared minus 6x squared is negative 1x squared, or you can just write negative x squared. Careful here, negative 7x minus negative 8x is a positive 1x. And then same process as before, guys. You are supposed to still bring down that next term. And then you start all over again. So lead term, negative 1x squared divided by x squared. It's going to give you a negative 1. So that gets written up here. And then you take the negative 1 and you multiply it into that big divisor. So you get negative 1x squared minus 3x plus 4. And then this is going to be our last step because we have no more terms. Let's see how far off we are. I messed up my colors, didn't I? Sorry. Okay, lead term cancels. It does. Next term, I'm just going to try to fix my colors so I can stay consistent. Lead term's gone. 1x minus negative 3x would be a 4x. And then 6 minus 4 will be a plus 2. So, this is the remainder. Your quotient is 2x minus 1. And then to write the remainder, the 4x plus 2, the thing being a remainder means you're still stuck in the division problem. There's one more thing you should look for. It's not going to be a huge issue unless you're like looking at one of the homework questions, but sometimes this remainder fraction simplifies. Like for instance, you can factor 4x plus 2 and you can factor x squared plus 3x minus 4. Like you could take a 2 out of this. Whoops. Hello, 2x plus 1. But notice when I factor this, x plus 4 times x minus 1, none of the terms are going to cancel. So you didn't have to go through that step of factoring. But there is one on your homework, I know for sure, where if you factor the numerator and denominator of that remainder term, something does cancel. So watch out for that one. All right. We'll come back and do more long division tomorrow. Let's back up a little bit and let's remind ourselves how to do synthetic division. You guys like synthetic division a lot more than long division. Synthetic meaning fake. So this is one you're just going to watch for a minute. Synthetic division is you set up fake division, which means there's actually no division in it whatsoever. You take the solution to the divisor. So if you were to solve that divisor, you'd get a -1, and that's what you place inside of that little half box. And then you take the coefficients of your dividend in standard form order, watching out for any missing terms. So there's 3x to the third power. Do you notice how there's no x squareds? And then there's a -2x to the first, and then all the way down to the constant of -4. Synthetic division is called fake division because it doesn't involve any division. It's actually a series of multiplications and additions. So you start by bringing down your first coefficient, and now starts the process of multiply, add, multiply, add. So you multiply these numbers together, and you write the product right here. And then you add up the column. So 0 plus -3 is -3. And then you do it all over again. -3 times -1 is +3. And then you add those up. And you get +1. And then +1 times -1 is -1. Why am I not changing my colors right? And then when you add these up, you get -5. Now, this last number you get in synthetic division, this represents the remainder. These guys are the coefficients to your quotient. So if you look at the original problem, you were taking a 3x to the third and you were dividing it by an x to the first. So this term right here is the lead-off term for your solution, your quotient, which is going to be 3x to the second. And then you just go down in line for standard form after that. So 3x to the second minus 3x plus 1 for a constant. And then instead of saying plus -5, let's just say a subtract and then 5 over. It's a remainder because it's still stuck in the division. Way back at the beginning of the problem, who was your divisor? X plus 1. So the drawback to synthetic division is once you go through the synthetic division steps, your answer isn't quite done. You got to go back and think about what all these numbers represent. So let's find some synthetic division practice for you. Is this one on your notes somewhere? All right, let's do this one together. So you set it up by doing this little half box thing. What goes in the half box is the solution to your divisor. So the solution to this divisor would be -4. And you're going to set up your coefficients in standard form order, but be careful, you are missing a term here. So it's 1x to the third. There are no x squareds. There's a -28x and a -48 for the constant. Okay, lead-off term comes all the way down to the bottom, and that's going to be where we start. All right, here we go. Multiply. So 1 times negative 4 is negative 4. And then we add them up. You get negative 4. Repeat. Negative 4 times negative 4 is 16. And then we add them up. And what is that, negative 12? Yeah? Okay. And then negative 12 times negative 4 is positive 48. Add those up, and we get a 0. So remember, this last number you get is your remainder. So in this case, it divides evenly. And your job is to take these coefficients and write them in place of each term and where they go. So you started off with an x to the third divided by an x. So this first term of your quotient is going to be 1x squared. Minus 4x's, and then minus 12. No remainder, so you don't have that weird fraction thing. Okay. So here's what you're going to do for me for homework. You're not going to be able to go very far in your homework. So you're going to finish 4B. Those 3 problems where you have to write those equations. That's super fun time. And then on page 115, you're eventually going to have to do all of the assignment, guys. So don't get excited. But for now, let's go ahead and stop at number 20. So you're going to do number 8, 16, 19, and 20. So 1, 2, 3, 4, 5, 6, 7 problems for homework tonight. You got this. Too much. Too much. All right. Best wishes. Good luck. We'll continue on with synthetic and long division tomorrow.